Week 5, steering and control, and we're talking about electric meters. We already used all the meters, but I'm going to tell you how they work, how do they function, which one is appropriate for what. And I still see people, when I tell them to go measure the amperage, they will go and use the leads. For the amperage, you need to use the clip-on meter. Correct?
Yes.
And if you clip it in both high and neutral, what you get?
Zeros.
0. Everybody agree?
Yes.
If you clip the ammeter on both wires, you will get 0. Because they will cancel each other. Because what are we actually sensing here?
The difference.
Yeah, but what are we sensing?
The bulb, the power, the bolts.
It's not, nothing is touching, it's in the middle.
Magnets.
The magnets, the electromagnetic force around the wire, which sometimes can be very small. That's why in the last lab I said, how do you measure very, very small amperage?
You coil it.
Yeah, because it's very small, you cannot measure the magnet.
And then you divide it by 2 once you
By
coil
the number of loops. So if I want to measure very small amperage, I'm gonna loop it twice or 3 or 4 times until I get a reading. Then whatever reading I get, I divide by the number of loops. Why? Because this is the law of coil. We'll see that in the funny video. How the coil makes the magnet stronger. Okay? So electric meters. We'll talk about the use of voltmeter, volt ohm meter, clamp ohm meters in our industry. How do they work? We don't need to know how much they work. And they try to tell you what is the difference between digital and analog. Nobody uses analog anymore. I hope not. The analog one is with the needle. Now everything is digital. Now what is the accuracy between them? How much accuracy do you need? There are some multimeters that are $400. The Fluke, for example, are planned because they are very accurate and give you very, very small reading. We'll talk about analog a little bit, if you have to use it, at least to know how they work. Describe the operation of analog meter. So basically, they are going to use the magnet to move that needle back and forth. If you've seen the old time amplifiers and those needles going back and forth, that's basically measuring the amount of magnetism in the wire. Describe the operation, analog, advantages and disadvantages. And what is the price of multimeter depends on. So you can see you can get one for $20 and you can get one for like $400. That's a big difference. Depends on the reliability, depends on the accuracy, durability. There are some meters where you drop it once and it's gone. So how well it's made, the warranty on it, and how often they give you free calibration. We'll talk about that as well. Source of energy. Does this need a battery?
Yep.
Yes. So sometimes if you are using analog meters, some of them don't even have battery. This is basically almost going in practice. So if I'm measuring voltage, I don't need to have any source of energy because there's energy in there. I'm just gonna put my leads in there and it should measure. The battery here only is used to turn on the screen. I'm using amperage. Again, I have a magnet here with a needle that interact with the magnet around the wire and it will move if you're using digital. For the resistance, you always need a source. It's just resistance. It's dead. Nothing's going through it. So I need some kind of voltage so I can go through the resistance and measure difference. And that's why you need to have a battery. Key terms, ammeter. Measures what?
Amperage.
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 Analog meter. Analog has a needle, goes back and forth. It's not digital, meaning it does not have numbers. Clamp on meter. That's the clamp on meter because it has a clamp. It's necessary.
Pretty.
Yeah, good name. Continuity. Do we know continuity?
Continuous.
Yeah. Did we use that function? Remember?
For, like, it reads whether or not the circuit is open
Yeah.
or not.
Make a noise. That's continuity. You put in continuity, it measures the resistance, if there's any. If there is no resistance, there is no continuity. And the voice function is actually nice to help you so you don't have to look for small resistance. So that's continuity. Digital is what we have here. This is digital. Magnetic field, it's a magnet that is generated around the wire. So every wire that has current going through it generates a magnet. Measurable resistance can be 0.000 ohm, small milliohm, but there is some kind of resistance. If there's not, if it's open, probably it's not going to measure anything for you. Some very sensitive multimeter can measure small resistance even through air. Yeah, so you have to give, that's why they have a range, and they will tell you what is the resistance. Because air is also conductive, but that's very small accuracy. Ohmmeter, what does it measure?
Resistance.
Open. What is open circuit? That's from last week's lab.
Wire is open to the
Yeah.
atmosphere.
Yeah, it's cut. There's no complete circuit. Short,
Touching something other than circuit.
this is a short circuit,
Yeah.
That's open.
but it's still running.
Sure. Yeah.
This is a short circuit. If it's both of them, that's open.
Okay,
Yeah.
yeah, because then there's.
Nothing's
contact,
going.
Yeah.
Yeah, nothing's going.
If there's one of them there, then there's still some contact. Yeah.
So now this is a short circuit.
Yeah.
We're missing one part, but it's, the system is not running. Open is completely not running. Voltmeter measures what? Volts, and you need the lead. Volt ohm multimeter. These are these tools which has everything in it. So back in the days, they used to have a multimeter, ohmmeter, a voltmeter, ohmmeter, and anemometer, big tools, big box, so you can measure everything by itself. This has everything. So these are the main things we need to measure, which is the components of Ohm's law, volts, amps, and ohms. And lastly, we have the ohmmeter, which you need the ammeter, which you need to measure with the clamp on. Okay, so as I said, if you got one thing out of this class, by the time you finish is using the multimeter, you'll be good, because that's what you need to use in the field. All the other stuff, the math and whatever, it's important, but not that essential to your job. So I'm gonna focus on the practical part. This is only a small portion of the class. But this, in all fairness, if you know how to use this, I'll be very happy. So we'll see. Get more practice, and again, if you buy your own, you can practice more and to take a measurement. So they used we use this device to measure these are the type of voltmeter, ammeter, and ohmmeter. So what we need to measure is to see if the system is continuous, and you've seen if we plug everything in and nothing works, the first thing we do is what? Measure for continuity. We want to make sure that the three components are there, otherwise there is no work done. First thing, you can go measure the voltage in the source. We have voltage, okay. There's voltage in there, make sure it's 118, it's not 40. You might get less than 118 because there's a short in the circuit. So you want to go and measure the voltage and make sure you have the right amount of voltage. Second, you will go and measure the continuity. Make sure the circuit is completely continuous, have complete path. Excellent, it's complete path. Then, you're gonna go measure the components. Each component, you're gonna measure the resistance. If the motor, if you put your leads in a motor in the input and you get 0, that means the motor is not running. What about the light bulb? Same thing, it's broken. So these things will help you diagnose the equipment and know which part you change. And also, you don't want to change a part that's not broken. So you always want to make sure that this is the part that needs to be replaced and do that. Another questions that I also seen happening in the lab. Do you measure resistance while the system is on or off? We agree?
Yes.
Otherwise, you're gonna get wrong and faulty reading. And if the multimeter is not protected, probably gonna blow your multimeter. So those cheap multimeters, they don't have like foolproof safety. Some of them do not have fuse, so you might go on, put in the wrong setting, and it's on you, it's gonna break. How about amperage? Is the system on or off?
On.
On. Otherwise, we're not drawing anything, right? There's no flow. So what am I measuring? What about voltage?
On.
System has to be on. Otherwise, there's no voltage coming through.
From the
Okay.
source.
Huh?
From the source.
Yeah. So what do they do? Again, it's basically saying the flow of electrons through the wires, current, etc. But we are measuring the magnetism going through a wire. This is a wire with a current going through it. It will, by default, generate a magnet from north and south. So when we clamp this meter on it, we are measuring this magnet. So there's a counter magnet inside to measure this flow. So again, magnetism, and also we can measure the current going through a resistance. There is a resistance inside. And if you notice in this multimeter, there's ranges: 2 ohms, 20 ohms, and 100 ohm. Why? Because you need to put it at the right resistance and the right magnet to measure the amperage. Some meters, they are auto ranging. What does that mean?
The what?
Auto range.
O2 range.
Auto range.
They have like, multiple.
Oh, auto.
So there's not a preset range for it.
So basically, you don't have to have any range. It's auto range. So you just put it.
in, that's it.
Yeah, you just put an amperage, and it will deal with it.
So like, what if, like, if one of these, so you don't have to like switch it?
Yeah, you don't have to switch it.
So you just put in that's it and it tells you whatever it is?
Yeah. So you see how there's three of these amperage ranges.
Yeah, so literally just put in
Yeah.
that's it.
The other ones will have only one, and it will arrange itself.
Oh.
So that's another function that you can have.
What if you put it on the wrong amperage reading, what would happen?
If it's auto protected, it goes not a big deal. It will give you zeros. Probably it will give you the measurement, so you go up to the next. There. So this is the magnetic field that's generated around the wire, or a cable. Actually, a wire, not a cable, because a cable is a bundle of wires. So you're measuring the force around it. Again, there's a pole coming north and south. So when we measure two lines, so this is going this way, and we have the other way, the other wire, which is neutral. This will go maybe north and south. So if you clip it in both, and they are the same amperage, they will cancel each other out, and you get a zero. So we don't see this field, but it's there, it does exist. Differences. So analog meters, they have a needle that moves, there's movement going on, and it's very difficult to read. Well, more difficult than an HD number, but there's a number in front of you, just read that number. For digital, there's a dial, and you have to read from the dial. Circuit is different. There are different resistances and load that react and move a needle to tell you what is the resistance. For ohm meters, they use devices. There's a device check to check the load and tell you what is the resistance, and it also has an internal battery, usually 9-volt battery to send some kind of voltage and measure the load. So these are analog meters. A meter, we said that before, it measures the magnetic field around the wire. How strong is the field? And the strength of the field depends on how much amperage you're drawing. Which again takes me to another, looking forward, how do we increase the motor speed? You can add more power to it, right? It will increase speed, so it means more magnet. Because the motor runs on the magnetic motor principle, which means more magnets to move things around. So you can increase the speed of a motor by increasing the amperage going through it, or by changing the winding. So we'll talk about that also after we finish watching the video. So probably Bill, how do you do that? This is the three-phase,
Bless you.
either a three-phase motor, compressor, or two-phase with the ground. If you put the clamp on the ground, would you get anything?
If you put the clamp on the ground?
Yeah,
No.
Ground wire.
yeah,
Oh, ground wire?
yeah.
Yeah. Because the current flows
No.
to the ground through the
I
wire.
say that
no?
it's too much. To a ground
Doesn't
wire.
the, doesn't the current flow through the ground wire to the ground? Instead of through-
If there's a short.
Should read zero. In
Zero.
the opposition.
Yeah.
Because the ground should be dormant until there's a short in the circuit.
Exactly.
So if you put it in the hot, it should give you a reading. You put it in the neutral, it should give you a reading. If you put it in the ground, you should get nothing. Unless, if you read something, that means there's a short.
with
It
your
should
ground
be zero,
wire.
yeah. There is something touching the casing. There's a wrong faulty wire going somewhere. So you clamp it on the hot or the neutral while the equipment is running. If you plug in the compressor and it's not running, you hear nothing. So you go and try to put it on your clamp meter, and you get some reading. What does that mean?
Short.
Huh?
Short.
Oh, I think a little bit. It's not running. Turn it on, not running, but you go on and clamp it on, and there is reading. It is seized. It's trying to move. It's drawing amperage. It's gonna overheat, but it's not moving.
So it's gonna overheat.
It's either overheat or stuck, but it's drawing amperage. Try to resist some kind of movement. Something stuck in there. It's not moving, but it's drawing amperage. So that's a good thing to remember. Question? Voltmeter, same thing, and some of them again you have to put it on the right reading, and it uses a resistance inside of it as protection measure. And again, a lot of these are fused. If you see there's a little compartment here, we can change the fuse in case you put it in the right setting and you have too much amperage going through it, it will break the fuse. Ohmmeters again, they are very important to measure the continuity of the circuit. They will show you if the circuit is open. So back in the days when we used the analog one, you can get infinity. It will show you infinity. What does that mean?
It's open.
It's open. And why is that? Because there is zero resistance, and you divide it by zero, and you divide by zero, you get infinity. So that's in the past. I'm sure you don't go through that, but this is good to know. It will also tell you what are the open components, where there's no resistance going through it. Direct shorts, like here, that's a short. So I'm gonna go and test the circuit. First of all, I'll measure the amperage. If the system is ready to draw 5 amps, so I'll go here and clamp it on, I get 4 amps. Okay, it's not drawing the right amount of amperage. I'm gonna go set it on resistance, check continuity, the amount. Continuity is gonna be in here, you get nothing. Make sense? We talked about continuity, if there's a complete path or not. These are some digital ones. 0, 15, that's no resistance. Infinity, there's a completely walking path. And here, this is a short, there's no resistance, no measurable resistance. The correct path. Here completely, you get nothing. It gets a little confusing, but don't read too much into it. The way I think of it is short, there is some kind of a path. Sometimes it's measurable, sometimes it's not. And a short, an open that there's nothing at all, zero resistance. And sometimes you get a reading. Compressor. So why are we measuring the resistance in a compressor? Of course, you have to turn it off first. Why am I measuring the resistance of the compressor?
Because it's a load.
Yeah.
It should have a resistance.
Yeah? And if it should give you how many ohms you should get for the winding. If you look inside a motor, I'm going to show you more quickly. So if you look, this is inside of the motor. What are you seeing here? What is this called? A coil. It's a winding, called winding, and this one should be continuous. If it's not continuous, it's going to give you open circuit. If it has a short in it, it will give you less amperage, less ohms than what you're supposed to. So if you go read the manual for this motor, it should tell you what resistance you should expect in this. And if you look at these bundles, they're kind of intertwined in a certain way. So you want them to go with the same direction. And sometimes it can get burnt partially or completely. So that's why you check the resistance for a motor. This is the wire for inside the ohmmeter. As we said, there's always a battery because you need a source of energy. And this is chapter 4 in the book. Friday I'll go over the questions at the end of the book. But there are a few questions that are very interesting that you'll find in the book. Basically the accuracy. What is the accuracy of digital versus analog? And what else? I think if you go over, so if you look on page 67, it will tell you that the digital has an accuracy of plus or minus 1%, which is pretty good. That's for the digital. And for the analog is 2%. So 1% is better than 2%. So digital is double the accuracy of analog. Okay, so I'll stop here on Friday.